Okay, let's take a look at what we did with a parabola last time. We defined the parabola. We derived this equation for a parabola. Last name?
There we go. Adrian.
Good deal. All right, we defined a parabola to be that set of points in a plane equidistant between a given point called the focus and a line called the directrix. That set of points will describe a parabola. Okay. The general equation of that parabola, we found out, is x minus h squared equals 4p y minus k. This gives us a parabola with a vertex at hk the distance from the vertex to the focus is p. Okay, so the focus here would be hk plus p. The directrix would have the equation y equals k minus p, assuming p is positive number. Okay, this is p positive. If p is negative, the parabola opens down. Okay. If it's the y that's squared, it's going to open right or left, depending on p being positive or negative. So what's going to happen here is you're going to be given an equation. You're going to have to complete the square on whatever variable that's squared. Put it in this right form. Once you get it in this form, you'll have the coordinates for the vertex, and you'll know the distance from the vertex to the focus, from the vertex to the directrix, that distance being p. And you'll be able to answer those questions. That's what's going to be asked of you on WebAssign. And that's what we did yesterday. Any questions on that? Anybody at all? Okay. One very important property of a parabola, which I will show you as soon as I get Mathematica going, okay, is the fact that lines, parallel lines that intersect this parabola will bounce off and all coincide with the focus, to be concurrent with this focus. A very important property of parabolas, okay? And like I said, I have a demonstration of Mathematica that proves that shows that. I will show you sometime, okay? All right, any questions at all? All right, let's go on, let's take another, another conic section. Let's take a look at a circle. This should be old stuff. Circle being the set of points in a plane, a given distance from a given point. Okay. The given point is the center. Let's start our center at 0, 0. Okay. If a point is to be on this circle, what must be the case is that this distance must be the given distance. Let's call that r for the radius of the circle. So if a point's going to be on the circle, it must be the case that this distance x minus 0 squared, y minus 0 squared is equal to r. Okay? Because every point on the circle has the same relationship. Okay? The distance from the point to the center is a given distance, r. This is the distance formula. Square both sides. X squared plus y squared is r squared. The equation of a circle whose center is 0, 0, whose radius is r. Okay? That should not be anything difficult. That should be old stuff. Okay?
Did you move the paper?
Yeah, paper. Yeah, I have a habit of doing that there. Good call. Any questions on that? So here's what's going to happen. You're going to be given this. You're going to be given something like this. Yeah. No, you're not going to be given that. something like this. First of all, you're going to be asked to recognize the conic section. This is a circle because the x squared and y squared have the same coefficient, okay? Coefficient of 1. You're going to complete the square for the x's and y's in order to put it in the right form. And that right form, the general form of the circle, will be x minus h squared, y minus k squared equals r squared. That moves our circle from the origin to a center of 0, 0, hk with a radius of r. Now, can you still see it?
Squared, right?
What's that?
It's a plus y squared, right?
Plus y squared. This scribbled thing here, yeah, that's to be ignored. Okay, so we want to get it in this form, which is the equation of that circle whose center is hk, radius r. We complete the square. What do we need to complete the square on the x's? Plus 9. We'll add 9 to the other side as well. What about the y's? Thank you. Okay. We'll have x minus 3 squared, y minus 1 squared equals 25. Equation of a circle. Center. Thank you. And radius. Thank you. Nice. Okay. Any questions on that?
The last step, one more time.
The last step is the center is 3, 1, whatever makes these 0. And the radius is 5. This is r squared here. Take the square root. Okay. Any questions on that? Let's suppose this came out to 0 here instead of 25. What would that tell you? What do you have in that case? A single point, which is sometimes called a degenerate circle. Okay? It's a circle of radius 0. Okay? Anthony can identify with that. All right, so. Yeah. All right, I'm not going to spend any more time on a circle. We all set with that? All right, let's go to another conic section, the more generalized circle, to an ellipse. Okay. We can define an ellipse by the set of points in a plane, the sum of whose distances, okay, from 2 points is a constant. Let's take 2 points. Let's put them right on the x-axis. First one is a focus. We'll call it F1. And we'll call the second point F2, the second focus. These are foci. Okay, let's start here. We want the set of points in the plane, the sum of whose distances from these 2 points is a constant. Okay? So, if we had these 2 points on a board, a cork board with thumbtacks, okay, and we took a piece of string, a constant length of string, and we put one end here and one end here, and we put a pencil here, and we went around so that the sum of the 2 distances is a constant, it would describe an ellipse. The set of points would describe an ellipse. So every point on this ellipse is such that the sum of these 2 distances is a constant. Okay, and we can take any 2 points at all. Sum is a constant. D1 plus D2 is our constant. Okay. All right. Here, we're going to call this A0, 0B. A is greater than or equal to B. If A equals B, we have a circle, a special case of the ellipse. A will always be the greater of the 2. If A is underneath here. The equation of this ellipse, I'm just going to give it to you. Algebra deriving is messy, so I'm just going to give it to you. The equation of this ellipse is x squared over a squared, y squared over b squared equals 1. Okay? If a is greater than or equal to b, if a equals b, we have a circle. If a is greater than b, a is called the semi-major axis. Okay? Rush. Okay. B would be semi-minor. Okay. It is always the case that A is the semi-major. If it happens to be under the y, then the ellipse would be orientated in a vertical way. Okay. So let me give you an example. Let's suppose we have x squared over 9, y squared over 4 equals 1. Center of the ellipse, 0, 0. Okay. A squared is 9, A is 3. Length of the semi-major axis. B squared is 4, B is 2. Semi-minor axis. And this would be our ellipse. Now the question is going to be, how do we find the foci of this ellipse? Okay, I mentioned that the Earth goes around the sun in an elliptical orbit. The center of the sun is one focus of that elliptical orbit. There is another focus, some point. It's given a name. I don't know what that name is. I'd be curious to find out what that name is. The other focus. There is a name to it. Nobody knows it though, but there is a name. Anyhow, that's okay. Any questions on this? And just to complete this thought about the semi-minor and majors. So let's suppose we're at x squared over 4 and y squared over 9. Okay. A squared is 9. A is still 3. Okay. A is always the greater of the two, but it's in the y direction this time. This would be this ellipse. That vertical, oh wow, oh geez. Hopefully you can draw it better than that. Wow. Yeah. Okay. How we doing? Doing all right? Okay. All right, a couple things we want to do here. One thing we want to do is locate the foci. Two things we want to do is move it off the center off the origin. Let's locate the foci first. So here we go. Is everybody okay with that? Everybody's all right with that? Okay, let's take an ellipse. Okay, here's what we do know. That no matter where we are on the ellipse, the sum of the two distances from that point to these foci is a constant. So let's take this point right here. This distance plus this distance. What's D1 equal to? What's that distance equal to?
D2?
What is it?
Or,
It's well, in the point that I've chosen, D1 is equal to D2. That need not be the case. Yes?
C minus D2? Your constant minus D2?
Wait, what are you saying? What are you saying, Liam?
D1 equals your constant minus D2? D2.
Okay, and the constant you're saying is C?
Yeah.
C are the coordinates of the focus, foci, okay? And I'm saying D1 is the distance from this point to a focus. So I'm saying that distance is equal to what? And you're saying it's something, and I'm saying, nah, not really.
Yeah, no, forget it.
Okay,
Go ahead.
not a big deal.
Some constant minus D2?
You guys are making it too complicated.
Square root of C squared.
Yeah, who's talking to me? Yes, go ahead, say it again.
Square root of C squared plus B squared.
Yeah, let's do it. Square root of change in x, 0 minus a negative c, or c squared, and b minus 0, which is b squared. So it's square root of b squared plus c squared. Okay? It's the distance between these 2 points. That's what D1 is. Okay? And what's D2 equal to? The same thing, yes. B squared plus c squared. Okay? The sum of those two distances is equal to 2 times the square root. Okay? Now that sum is going to equal the sum of the two distances from any point on the ellipse. That's how you get any ellipse. You take all those points in the plane, the sum of the two distances from those two foci is a constant. In other words, let's take this point now, and let's take the two distances to this point. One will be this distance here. I'm going to call this D3. And the other distance is this. I'll call it D4. All right, here's what I need from some super student. D3 is equal to what the heck is that distance equal to?
C plus A.
It's equal to, say it again,
C plus A.
B plus A?
C plus A.
C plus A. Yes. I'll go with A plus C. Dan, no offense, but I'm going to go with A plus C. Okay? This distance is A plus this distance C. Okay? And what's D4 equal to?
A minus C.
Is A minus C. Exactly right. Okay? All right, let's stop here. Is everybody okay with this? Dylan, you okay?
Yeah.
Oh, that's your okay face? Oh, okay. Omar.
Oh, never mind. Okay, I was about to ask where D4 was.
Yeah, D4 is this guy right in here. Okay, so let's take D3 plus D4, which is A plus C plus A minus C, which is 2A. Okay. You with me on this? And what do we know is true? We know that D1 plus D2 must be equal to D3 plus D4. Because that sum of the distances is equal to a constant no matter where you are on the ellipse. That's what an ellipse is. And what's D1 plus D2? It's twice the square root. And what's D3 plus D4? It's 2 times A. Let's knock out some 2's. Let's square both sides to get B squared plus C squared is equal to A squared. Okay? That's the relationship that we need to determine C. Okay? You're going to be given A and B, or at least be able to derive A and B from the equation of the ellipse. And once you know A and B, you use it to find C. And please note, A has to be greater than or equal to B. What happens if A equals B? What happens to C in that case? C equals 0, and we have a circle that's centered at the origin. Okay? All right, how are we doing? We're doing all right?
I'm a little confused.
Oh, go ahead.
You see, I always just thought it was A squared plus B squared equals C squared.
Yeah, Pythagorean Theorem, it certainly
Now it's
is.
all mixed up.
That's a good call. In a right triangle, it is the case that A squared plus B squared equals C squared, and C is always the hypotenuse in that right triangle, Pythagorean theorem. But when we're talking ellipses here, and A is the length of the semi-major axis and B is the length of the semi-minor axis, it is the case that B squared plus C squared is equal to A squared, where C is the distance to the focus. Just the way it is. Sorry about that. And I got to tell you. What's that?
I was going to say, could you draw out a triangle with that?
Yes, you can. You could draw a triangle with this. Not easily, though. What the heck? What triangle?
Not like, so we turned that Illuminati pyramid thing into a right triangle. So could you draw in what you mean?
Okay, B squared plus C squared is equal to A squared. Okay, hold on a second. B squared plus C squared is equal to A squared. So A, that doesn't work well, man. This would be A.
So if you knew what D2 was, you could use.
Yeah, if this would be equal to A. So C squared plus B squared, D2 would equal A. That's what that proves. Because here we have the right triangle right here. This is B, this is C. B squared plus C squared is equal to A squared. A would equal D2. That's what you're talking about, right? Good. Nice. Okay? D2 would equal A. That's what we just proved by doing that. Okay? Does that make sense? Oh, good. What else do we have to do here? We have to move the ellipse off the origin. Okay, so let's move it off the origin and get the general form for an ellipse. The general form for an ellipse is x minus h squared over a squared, y minus k squared over b squared is equal to 1. Okay. The center of this ellipse is hk. Okay. Semi-major axis is A. It has length A. Okay. Semi-minor axis B. And B squared plus C squared equals A squared. Okay, you ready? Let's do it. Okay, everybody okay with this?
Just 1 second.
Okay, no problem. How you doing, Brian? You doing all right? Good deal. Oh, I was going to mention, too, when we do hyperbolas tomorrow, it's not b squared plus c squared equals a squared anymore. It's different. So we'll have another variation on that same theme. But we'll do that tomorrow. And hopefully I'll have Mathematica tomorrow where I can show you the demonstration, too. Okay, how are we doing? Everybody okay? Okay. All right, so let's do one. Here we go. Let's do this. Let's find. This is the kind of thing you're going to be asked to do in WebAssign, and this is the kind of thing you're going to be asked to do on your first test as well. Find the center. Let's just go with semi-major axis. And the foci of, okay, let's go with x squared plus 6x plus 4y squared plus 8y is equal to, and hopefully I can do it so it doesn't come out real crazy, equals 12. Okay? Okay. First of all, how do you recognize it as an ellipse? The x squared and y squared, same sign, both positive, but different coefficients. If this had been a 4 as well as this a 4, it would be a circle, a special case of the ellipse. And we'll find tomorrow, if this is a minus, if they have different signs, then we have a hyperbola, okay? Same signs, different coefficients, ellipse. What you have to do is put it from this form and get it into the form of the general form for ellipse. All right, and that means completing the squares on each of these. So what do we need to do to complete the square on the x's? Add 9. Now, to complete the square on the y's, what do you have to do first? Factor out the 4. To complete the square, you have to have the coefficient of the square term be a 1. Now, what must I add to that to make it a perfect square? 1. What do I have to add to the other side to compensate? 4. Because what I've really done is added 4 to this side. Okay? So, x plus 3 squared plus 4 times y plus 1 squared is equal to 25. Check it out. Is that okay? So, Dan, what you're saying is every student here, when they download Mathematica, is going to have this problem?
Has the possibility to have this problem.
Even if we already have Mathematica from the summer?
Is it 10? If it's version 9, then it's fine.
Okay.
And if they do have a problem, then where do they go to get the fix?
I just looked up on Google Mathematica hanging on startup, and it brought me to
We go to see Dan.
All right.
Good job.
Sounds like a good solution right there. Yes? The 9 comes from taking half of the 6, 3, and squaring it. That's how you complete the square. Half the coefficient of the x term squared. Where the 1 comes from is half the coefficient of the y term would be 1, squared is 1. Okay? That makes it a perfect square. Okay? We don't want the 25 there. That has to be a 1. We're going to divide both sides by 25. Now, here's what else I want to do. This would be 4 over 25, but I don't want to write it that way. I want to write it as 25 over 4. Okay? It's the form that I want it in. That's my b squared. Okay? Everybody with me on that? Instead of taking the 4 in the numerator, divide numerator and denominator by 4 to get this, and that's equal to 1. This is the general form for an ellipse. This is your objective. This is where you want to be. Okay? Okay. Let's answer the questions. What's the center of this ellipse?
-3, -1.
You bet it is. That away. -3, -1 is the center. Okay. We have a horizontal orientation because the a squared, 25, is greater than b squared, 25 fourths. What's a in this case? And b? 5 halves. Okay. Okay, the a gives you the distance from the center to the, it's a semi-major axis, it's 5. So this will go over here. So it's 2, -1. Go 5 in this direction. So we end up with -8, -1. Okay, that gives us a distance of 5 for our semi-major axis. We're going to go up 5 halves this way for our semi-minor axis. 3 halves here. And down here will be -3, -7 halves. Boy, I hope, I think, I guess. So my ellipse looks like this. boy, this is a genuine pain in the neck to do this. Okay, that's the ellipse. And now we have to find the two foci. In order to find the foci, we're going to have to find out what C is. Okay, well, to find C, what do we know? We know that B squared plus C squared is equal to A squared. B squared plus C squared is equal to A squared. (25/4) plus C squared is equal to 25. C squared is equal to 75/4. Hopefully. So, C is equal to,
5 squared on 3 over 2.
yeah, that's it exactly, over 2, yeah. Take the square root of 75, okay? 25 times 3, 5 square roots of 3 over 2. Holy moly. So here we go. One focus. Call it F2. This is F1. Is equal to -3 minus 5 square roots of 3 over 2, -1. Nice answer, you stupid problem. And the other focus is -3 plus 5 square roots of 3 over 2, -1. Wow. I don't know, WebAssign may give you something like that too. I think, I don't know, maybe. Some of the answers in WebAssign are real messy, I know that. Wow. What do you think? Yeah, I agree with you. But that's what it is, okay? Check it out. Any questions on that? It's the kind of thing you're going to be expected to do. Certainly on a test, when I give you this on a test, you're not going to get numbers like this. There'll be much nicer numbers, guaranteed, okay? Probably be a liar here, probably, all right, but hopefully they will be better, okay? All right, so here's what you should be doing for tomorrow. You should be getting on WebAssign using the code that I gave you, that Dan gave you actually, and starting the first homework. The first homework is on the conic sections. We still have one more conic section to go, and that's the hyperbola, and we'll do that tomorrow. Right now, I'm going to make a copy of the notes, and Dan's going to fix my machine. Dan, you should be receiving a stipend of some kind for this class.
Oh, wait.
Instead of keeping them.